Hello students and welcome to Crop Science 6049. In today's lesson we are going to look at water potential and radial movement of water in plants. By the end of this lesson you must be able to explain the components of water potential and also to describe water flow pathways from cell to cell in plants. Let's take a look at water potential. Water potential is the tendency of water molecules to move from one place to another. It is also a measure of energy state of water. This is the work that water can do as it moves from its present state to the reference state. The higher the water potential, the greater the tendency of it to leave a system. All solutions have lower water potential than pure water, since pure water is higher energy. So what are the components of water potential? First of all, let's take a look at pressure potential. Pressure potential is the component of water potential due to hydrostatic pressure that is exerted on water in a cell. Pressure tends to force water from one place to another. In turgid plant cells, it usually has a positive value, as the entry of water causes the protoplast to push against the cell wall. In xylem cells, there is a negative pressure potential or tension as a result of transpiration. Pressure potential increases water potential. Water at atmospheric pressure has pressure potential of 0. Next, let's take a look at matrice potential. Matrice potential is a component of water potential due to the adhesion of water molecules to non-dissolved substances of the system. Matrice forces are forces acting on soil water that are independent of gravity, but exists due to the attraction of solid surfaces for water, the attraction of water molecules for each other, and a force in the air-water interface due to the polar nature of water. Next, we want to look at the gravitational potential. Gravitational potential is due to the force of gravity that pulls water downwards. The last component that I'm going to look at is osmotic potential. Osmotic potential is the potential of water molecules to move from the hypotonic solution, that is, a solution with more water molecules and less solutes, to a hypotonic solution, that is a solution with less water and more solutes, across a semi-permeable membrane. Now let's take a look at the radial movement of water across plants. You may be wondering, what is radial movement? Radial simply means along the radius. So water will be moving from the soil across the root hair cells until it reaches the xylem. And also water will be moving from the xylem and across the cells of the leaves. Now let's take a look at the different pathways of radial water movement in plants. And I'm going to start off with the movement of water in the roots. Movement of water in the roots follows 3 main pathways. I'm going to start off with the vacuolar pathway. Vacuolar pathway is the movement of water molecules in plant cells via vacuoles located in the cytoplasm of the cell. The water molecules encounter high resistance, and as a result, little flow usually occurs, making this pathway insignificant. Water moves by osmosis across the vacuoles of the cells of the root system. The water moves down the concentration gradient from the soil solution to the xylem. The next pathway is the symplast pathway. The symplast pathway, it consists of cytoplasm network of every plant cell interconnected by the plasmodesmata. Symplast does not involve intercellular space and cell wall, and therefore considered as complete living component of the plant tissue. This pathway offers resistance to the flow of water since the selective plasma membrane of the root cells handles the intake of iron and water. Moreover, simplest pathway is affected by metabolic state of the root. The last pathway is the apoplast pathway. In the apoplast pathway, water passes from the root hair to the xylem through the cell walls of neighboring cells without crossing any membrane or cytoplasm. Because cell wall is pervious and non-selective, both water and all dissolved minerals may be carried this way. This pathway provides the least resistance to movement of water since apoplast is made up of non-living components and is least affected by the metabolic state of the root. However, it is blocked by suberin of the Casparin strip in the endodermis. Water is thereby forced to enter the living protoplast of the endodermal cell as the only available route to the xylem. Now let's take a look at movement of water in the leaves. The movement of water across the leaves occur in the same three pathways as in the root, that is apoplast pathway, simplast pathway, and vacuolar pathway. However, the apoplast pathway in the leaf is different from that of the root, as water is able to travel through the cell wall from one cell to another in the leaf without hindrance from suberin of the Casparin strip. When stomata in the leaf are open, the less negative water potential in the substomatal airspace then causes the diffusion of water vapor out into the atmosphere. Thank you for watching. Don't forget to subscribe to this channel. If you have any questions, additions and subtractions, please write them in the comment section. If you have benefited from this lesson, click the like button.